Today's conference is brought to you by the students of the Institute of Cognitive Neuroscience, located in the heart of Queen Square. As the largest centre for neurology and neurosurgery in the UK, Queen Square has, for centuries, brought together the most influential figures in the field, shaping the modern landscape of cognitive neuroscience. Given the profound contributions of the institutions within Queen Square to neuroscientific research, we wanted to take this opportunity to celebrate their legacy and impact. So, without further ado, let's meet Professor Sophie Scott, who will take us on a guided tour through these historic institutions.
Hi, my name's Sophie Scott and I'm the Director of the Institute of Cognitive Neuroscience, and in this short and very informative film I'm going to take you through some of the history of neuroscience, neurology, neuropsychology in Queen Square. So what we need to do first is to go out into Queen Square.
As you can see, it's a rather short commute to our first stop, the National Hospital for Neurology and Neurosurgery.
Welcome to Queen Square. Behind me is the National Hospital, and the National Hospital is the first hospital for people with neurological disorders. It was actually developed following an intervention by two sisters, the Chandler sisters, in 1859, who wrote to the Lord Mayor of London. They had a relative who they were very worried about, and they were worried about their care, and they were worried more generally about how people were getting access to care who had problems with their brains and their nervous systems. And the following year, the National Hospital was built and it started admitting patients, and it has remained a centre for neurological specialities in the UK ever since.
So now that we've heard about the history, let's dive into the research conducted at the hospital.
In 1862, the scientist and neurologist John Hewlings Jackson came to the National Hospital, and he was both a revolutionary physician, very interested in epilepsy, and made several really big steps in understanding epilepsy and what was causing epilepsy. And he was also very interested in aphasia, and he was one of the first people to note that, for example, children with aphasia could still sing, which is actually something people are still very interested in terms of understanding how speech and song are processed in the human brain. John Hewlings Jackson was one of the founders of the journal Brain, which remains an enormously important neurological and neuroscientific journal, which is still in print. You can get your papers published there. The neurologist and neuroscientist David Ferrier joined the National Hospital in 1873, and he was one of the first people to map out structure and function on the cortical surface, so that's sort of the wrinkly grey surface of a human brain.
Now let's turn our heads a little bit to the left and knock on the door of one of our neighbours, the Institute of Neurology.
It is the Institute of Neurology, and this was founded in 1950. It's actually in the process of moving over to a new site on Gray's Inn Road. This has been a centre for neuroscientific research. It sits right next door to the National Hospital for Neurological Diseases, and there's always been tremendous crosstalk between the two institutes. And there have been some really enormous developments in the Institute of Neurology. In 2002, John Collins discovered prions, units of disease which could transmit a form of bovine spongiform encephalitis in humans, called a variant of Creutzfeldt-Jakob's disease. So this has been an enormous development in understanding both BSE and Creutzfeldt-Jakob's disease, and also understanding this extremely unpleasant degenerative brain disorder. In 2015, the scientist Sarah Tabrizi, working at the Institute of Neurology, developed a method for providing potential treatments for Huntington's disease. Huntington's disease is a very unpleasant degenerative brain disease which is very strongly heritable, so if you have the right genes for it, unfortunately, you will start to suffer from this disorder. And she's using gene silencing to provide a whole new route for treatment for this really unpleasant disease.
Though significant advancements in neurology and neuroscience have come out of Queen Square, there are other disciplines that have thrived here too. Let's now take a step back to hear more about the origins of neuropsychology at Queen Square.
So in addition to neuroscientists at the Institute of Neurology and the neurologists working in the National Hospital, there were also neuropsychologists working at the National Hospital, and a really important figure in this respect is Professor Elizabeth Warrington, who started doing research into selected deficits that patients could experience following different kinds of brain injury. And a really big leap forward in the field came when she was having a conversation with Professor Tim Shallis, who was at UCL, and she was explaining that she had a patient who had very impaired short-term memory but quite normal long-term memory, and at the time the models, the cognitive models that we had of how memory worked, suggested that for something to enter into long-term memory, it had to go through short-term memory to start with. And Tim Challis realised that you had an example here of a case where the data from the patients would tell you what was right and what was wrong in your cognitive model, and the data that Elizabeth Warrington was telling about this patient's experience was that their cognitive models were wrong. And this was the start of what became known as cognitive neuropsychology and then cognitive neuroscience.
Now it's time for a change of scenery as we walk to Lamb's Conduit Street, where we will find out more about how neuropsychological tests have been created and administered to patients in real-life settings.
Behind me is Lamb's Conduit Street, and actually that's Lamb's Conduit Street, very nice street, nice place to get your lunch, but it's also the location where Tim Challis and Paul Burgess, who've been working with Elizabeth Warrington, looking at patients with selective injuries and deficits and how you could relate structure to function in the human brain. And they were working with groups of patients who had damage to the frontal lobe. And one of the problems with these patients and assessing these patients was that frequently, after damage to the frontal lobes, patients didn't have obvious deficits. So, for example, their intelligence measurements and using IQ measures were often preserved and their language skills could be fine. But once they'd recovered from their injury and they tried to do something like go back to work, this pattern of problems would emerge where they would really struggle in the workplace. They would make unusual decisions. They might be not good at dealing with money. And what Tim Challis and Paul Burgess wanted to do was come up with a different kind of neuropsychological test where they could assess what's actually gone wrong in these situations. So what they did was, instead of giving people a pen and paper test or asking them direct questions, what they gave them was a shopping list, and they took them to Lamb's Conduit Street, and the patients had to buy the things on the list. That requires you to be able to plan and gather together information and sort of approach it in a strategic way, and that's what these patients with frontal lobe injuries were really struggling with. So Tim and Paul would sort of hide behind lampposts watching people, tracking how they went about the task. Rather sweetly, the shop behind me that's now called Tooties, and it's a cafe, used to be a greengrocer's, and the greengrocer got very used to people coming in and used to go, "Oh, give me that list. This is where you can get a stamp." But what you would find is that people who didn't have frontal lobe injuries would look at the shopping list and then look at the shops and plan how they were going to go about it. And the people with the frontal lobe injuries would just, for example, go into a greengrocer's and demand a stamp. They weren't planning in the same way. And the multiple errands test, as this is now known, has become a really important way of studying frontal lobe function.
After exploring researchers' methods in clinical settings, you might be curious about how other forms of data, for example neuroimaging, have been acquired. This leads us to our next destination, the Wellcome Centre for Human Neuroimaging.
This is the Wellcome Centre for Human Neuroimaging, and people have been doing functional imaging studies here, looking at the intact human brain using techniques like positron emission tomography and functional magnetic resonance imaging since 1994. The first director was Richard Frakowiak. It lives within the Institute of Neurology, but it's a separate institute, and people have been doing really groundbreaking work in understanding mapping between brain structure and function by taking photographs effectively of the human brain in action and relating what people are doing to which brain systems are recruited. Some of the most famous studies from the Centre for Human Neuroimaging are by Professor Eleanor Maguire, who did work with London taxi drivers, and she was studying London taxi drivers because they do the knowledge, and doing the knowledge involves learning an incredibly complex set of routes and information about the structure of London's roads and how to navigate through them. And she was interested in this because she was interested in the hippocampus, a part of the brain that is known to be important for memory and for spatial navigation. And indeed, Eleanor found that the taxi drivers that she studied had got larger hippocampi than people who hadn't done the knowledge. So there really is, it's an amazing demonstration of the plasticity of the human brain.
Now that we've explored the major hubs in Queen Square, from the Institute of Neurology to the National Hospital to the Imaging Centre, it's time for us to return to our home institution, the beloved Institute of Cognitive Neuroscience, that which brought us here today.
So behind me is the Institute of Cognitive Neuroscience, and the students who've organised everything that you've seen today are all students who are on their Masters in Cognitive Neuroscience, based here. The Institute was set up by Tim Shallis in 1996, and we came physically to this location in 1998. And the aim of the Institute of Cognitive Neuroscience is to draw together many of the themes that we can see in the rest of the square: neurological studies, neuropsychological studies, neuroscience studies, studies of mapping the human brain. And what we are trying to do at the ICN is to map human experience and human behaviour into human neural function. So an example of the kind of research that we do here at the ICN would be Professor Mairead McSweeney's research, and she's very interested in sign language and communication with sign language, and she's done studies, for example, showing that people who are native signers of British Sign Language, so they have grown up always signing, recruit very similar brain areas to native spoken English speakers who have grown up speaking English, so communicating verbally with sound. So although we've got two different domains, visual signing and auditory speech, you still see some very similar brain areas activated, which is very strong evidence that sign language is another true language.
As we conclude our tour, we hope that this video has offered you a glimpse into the remarkable work that takes place within the confines of Queen Square. We are honoured to welcome you into our home today. As you've witnessed, the Institute of Cognitive Neuroscience thrives on collaborations between expert neuroscientists, clinical specialists at the hospital, and our dedicated young students, all of whom contribute to the body of excellent research you've explored today. So, thank you for joining today, and we hope that you will leave us with newfound insights and a curious optimism for the future of the field.